Welcome to students. Today we are going to discuss about the various loads coming on the bridge. We have to discuss in detailing in one by one. First of all, we have to see the types of the loading or different loading on the bridge. First, buoyancy force. Next, dead load. Third, live load. 4, seismic load. 5, water pressure. 6, wind load. 7, earth pressure. 8, impact load. 9, deformation stresses. 10, centrifugal forces. Next, longitudinal forces, and last one is the temperature variation forces. All the loading we have to consider at the time of the design of the bridge. We have to see that this loading in detail one by one. First load is buoyancy force. It is a force exerted on an object that is wholly or partially immersed in the fluid. The buoyancy force it is only applied on the object that is wholly or partially immersed in the fluid. The effect of buoyancy is considered in the design of bridge only if strata of soil is permeable or if foundation rests on the permissible strata. We have to consider that buoyancy force is the effect on the bridge is the only if the strata is the soil is a permeable condition or the foundation rests on the impermeable strata. Second load, impact load. The stresses developed due to fast moving vehicles over uneven surfaces. The impact load we have to know that suddenly apply the load on the surface of the object. The same thing, the stresses developed due to fast moving of the vehicles over uneven surfaces. Next, provision is made in the design for impact is expressed as the fraction of live load stresses. Such fraction is termed as the impact factor or coefficient of impact. Next load is the dead load. It consists the dead load of the structure itself and the weight of the superstructure. Dead load is nothing but the weight of this weight of the bridge and weight of the superstructure. It depends upon the length of span, live load to carry out working stresses in design. The dead load we have to consider or we have to calculate the length of the span or length of the bridge and live load to carried working stresses in the design. The dead load is initially assumed and checked and after design is completed. At the time of designing, the dead load have to initially assumed and checked and after we have to completing the design. Load is longitudinal forces. They should be considered in design of bridge. Braking effect resulting from application of brakes. Tractive effort caused due to acceleration of the during wheels of vehicle. The longitudinal forces we have to consider in the design of the bridge. The braking effect is resulting from the application of the brakes. And also the tractive effect is caused due to the acceleration of the during the wheels of the vehicle. Next, earth pressure. Component of bridge which are required to retain earth should be designed for suitable of earth pressure. The backfill retainer mass of soil exerts the lateral pressure known as the earth pressure on earth retaining structure. The earth pressure it is nothing but it's the backfill retainer mass of the soil that exerts the lateral pressure that is known as the earth pressure on the earth retaining structure. The position of live load on earth also causes the pressure which is known as the surcharge load and it should be considered in design. It's considered as that the position is also affect the position of the live load on the earth is also causes to pressure coming on the bridge. It's also known as the surcharge load and it should be considered at the time of the design of the bridge. Next is the water pressure. The portion of bridge which is submerged in running water is designed for the horizontal forces of water current. That this portion is the water pressure is coming on this especially in the pier of the bridge or pier of the bridge. This portion of the bridge is submerged in the running water or flowing of the water in and it's designed for the horizontal forces of the water current. For piers parallel to direction of water, the intensity of pressure is capital P is equal to kW square divided by 2G. For the calculating of the piers parallel to the direction of the water intensity, we have to using the formula, that is the P is equal to kW square upon 2G, where P is nothing but the pressure intensity due to water current, and next W unit weight of water in Newton per meter cube. V is equal to velocity of water current in meter per second. G, it is the acceleration due to gravity in meter per second square, and K, it is a constant depending upon shape of pier. For the calculation of the water pressure, we have to using this formula, that is the P is equal to kW v square upon 2G. Next load is the seismic load. If bridge is situated in the earthquake prone region or earthquake zone, the seismic force are given to consideration in structural design. If the bridge location in the earthquake zone, that time we have to consider that the design the seismic load. Earthquakes causes vertical and horizontal forces in the structure that will be proportional to weight of the structure. Both the horizontal and vertical components have to be taken into account for design of bridge structures. The bridge is provided with features to resist the effects of an earthquake. Due to the earthquake causes, the vertical and horizontal forces into the structure that will be happen, and it's proportional to the weight of the structure. And also it's the effect is the both the horizontal and vertical components have to be taken the account of the design for the bridge structures. The bridge is provided also the features to resist the efforts of an earthquake. Next, wind load. Wind is the main cause of the many of the forces that act on bridge. Wind can push the bridge horizontally, vertically, or in any other way. The major impact of the bridge is nothing but due to the wind load. The wind is the main cause of the many forces that they act on the bridges. The effect of the wind is or pressure of the wind is can possibility of the bridge is horizontally, vertically, or on any other way. Its effects are more significant on long span bridges than short ones. Its effect is or more effective in the long span bridges compared to short span bridges. It is directly proportional to square of velocity, and it is expressed as the P. The formula for the wind load is the P is equal to kV square. That is, P is the nothing but the wind pressure in Newton per meter square. V is equal to velocity of wind in kmph, and K is the constant depending upon meteorological conditions and nature of surface exposure is 0.051 to 0.095. To calculate the wind load, we have to using the formula to P is equal to kV square. Next load is the live load. Live load is the weight of traffic on bridge. The live load, it is nothing but the weight of the traffic or traffic moving in the surface of the bridge. The maximum live load will depend upon the situation of structural member under consideration. The IRC revised a recombination of for loading are Class AA loading, Class A loading, Class B loading, and Class 70R loading. As per the IRC recommendation, we have to for the loadings are we have to consider the various load, that is the Class AA loading, Class A loading, Class B loading, and Class 70R loading. We have to see one by one. First, Class AA loading. The loading are based on the heavy military vehicle likely to run on certain roads. This type of the loading we have to based on the heavy military vehicles such as the military tank to run the certain routes. All bridges on national highway and state highway are designed for this heavy loading. All the bridges in the India on the national highway, also on the state highway, we have to design the class A loading for the heavy loading. Two types of vehicles are specified in these classes. First, tracked vehicle of 700 kN and wheeled vehicle of 400 kN. There are the two types of the loading we have to consider or specified in the class. The first is the tracked vehicle. It is almost 700 kN and wheeled vehicle for 400 kN. The structures designed for Class A loading should also be checked for Class A loading, as under certain conditions we get higher stresses under the Class A. At the time of the design of the Class A loading, we have to also check for the Class A loading, because under certain conditions we get the higher stresses under Class A. In this image, you have to see the first Class A loading type, that's a tracked vehicle. This is the image of the military tank. As the weight of the military tank is 700 kilonewton. The total distance of the military tank is the length of military tank is the 7200 mm. The wheel distance is the 3600 mm. If this military tank, we have to get the section or cutting in the middle position. This is the section of the military tank. This weight 700 kN will be distributed equally into both the vehicles. First 350 kN and another 350 kN. Also, the distance of the first vehicle or three vehicles between the 850 mm and 850 mm. Remaining is the 1200 mm. This is the C. C is nothing but the edge of this vehicle to the edge of the tank. That is the 1200 mm, and for two lone carriageway of 7.5 meter. That is if there are the two or more tanks are traveling, that time the distance between the two tank is as per the IRC condition, it must be 7.5 meter. Next type is the IRC class A tracked and wheeled vehicles. If there are the some vehicles are present in the surface of the road, that is the first load is just 37.5, 62.5, next 62.5 and another 37.5 is a separate wheel load. The wheel coming on this load, the distance is the 300 mm. Remaining is the 300 distance between two wheels, 300. The wheel distance 300. Next, middle portion is the 700 mm. Next, single wheel distance is the 300. Next, distance between the two wheels 300 and single wheel is the 300. This is the wheeled vehicle. The separate wheel, you get the separate the load. This is the IRC class A tracked or wheeled vehicles. Next is the class A loading. It is based on the heaviest type of commercial vehicle which is likely to run on Indian roads. As at the time of the national highway or state highway designing, we have to consider the class A loading. This is the important design part or loading part to have to assuming or calculating this various loading. What is the class A loading? It is the heaviest type of the commercial vehicle which is likely to run on Indian roads. All permanent road bridges and culverts which are not covered by class A loading are to be designed for class A loading. All the permanent road bridges, if the bridge is the permanent structure, and also if the culvert which is not covered the class A loading, that time you have to design for class A loading. The class A loading specified for train of wheeled vehicle on 8 axles is 554 kN. Also we have to design class A loading for the train for the 8 wheels. The 8 wheels axle is the weight is the 554 kN. The axle loads are assumed to act simultaneously so as to cause maximum stresses. we have to consider the axial loads at the assuming the act simultaneously, so it is cause the maximum stresses, or it's cause the developing the maximum stress. Here we see that the 8 axle wheels, that this is the image of the IRC class A and B loading vehicles. It is a design, or this is the image of the class A and class B loading vehicles also. The weight of the vehicle, single vehicle, is the 27, second is 27, next 114 for the class A. Next vehicle, single vehicle, is the 68 kiloton. Next another is the 68 kiloton, and next the 68 kiloton. This is loading are for class A, and for class B is the 16 kiloton, next 16 kilometer, next 68 kiloton, next 68, 41, 41, 41 and 41. This is for the class B design. There is here seen that the axle load is the 114, the ground contact area, the B and breadth and width, the 250 mm and 500 mm. If the axle load is the 68, the B is the 200 and VW weight is the 380 mm. Next, axle load is the 41, then B is the breadth is the 115, width is the 300 mm. The axle load is the 27 kilonewton, then the breadth is the 150 and width is the 200 mm. And also last one is the axle load is the 16 kilonewton, then breadth is the 125 mm and width is the 175 mm. Next, class B loading. In this type of the loading is similar to class A loading, except the axle load are comparatively of lesser magnitude. This is the same, it's similar to class A designing or class A loading. The only different is the axle loads compared to lesser magnitude. The axle loads of the class B are 332 kilonewton, train of wheeler vehicles on 8 axle. This type of loading is adapted for temporary structure and timber bridges only. This type of the or class B loading we have to adapt, or we have to use for the temporary structure of the bridge and also timber bridges. The same image here. This is the 16 kilonewton single wheel load is the 16 kilonewton, 16, 68, 68, 41, 41, 41 and 41. This is the for the load is considered as the class B loaded. The total load is the 334 kilonewton. Next is the class 7-tier loading. This additional loading is sometimes used in place of class A. This is the additional loading we have to use for the class A loading. Then the tracked vehicle load is similar to class A, except the ground contact length is 4.57 meter and length of vehicle is 7.92 meter. In the tracked vehicle load is similar to class A, but it's the only different is the length and ground contact length is the 4.57 meter and length of the vehicle is the 7.92 meter. The wheeler vehicle is the 15.22 meter long with the 7 axle with loads totaling of 100 tons. The wheeler vehicle is the 15.22 meter long with the 7 axle loads totaling at 100 tons. The first type is the class 7-tier tracked vehicle. Suppose the direction of the vehicle is in this position, that time the total direction is the 360 kilonewton. We consider the first class 7-tier tracked vehicle. The total distance is the 2.9 meter, and we have to divide it. First wheel is the 0.84 meter and next 0.84 meter. Remaining distance is the 1.22 meter. Second is the type is this class 70 are wheeled vehicle loading. We have to consider separate wheel loading. The first is the 80 kilonewton axle load is the 80 kilonewton, 120 kilonewton, 120, 170, 170, another 170 kilonewton, another 170 kilonewton. The distance between this edge to this wheel is 910 mm. The wheel to wheel distance is 3960 mm. The distance between these two wheels is the 1520 mm. The distance between these two wheels is the 2130 mm. Then distance between these two wheels is the 1370 mm. Again, the long distance between these two wheels between the is 3050 mm. Next distance between these wheels the 1370 mm, and last is the this wheels to edge of the vehicle is the distance is the 910 mm. This is the image of the class 70R wheeled vehicle loading. That is the total load is the 1000 kilonewton. The total load of the axle load is the 1000 kilonewton. Okay, today we have to here stop here. In next lecture we have to see the remaining part of this chapter. Thank you so much.